attention, please. Our last present this evening, if you'll excuse the pun, the least, as in the smallest number, are Grant Waldy and Peter Dyes will be talking to us about CN Ryzuk.
Thank you, Darren. Well, because we have two people in the group, we're going to do the presentation just a little bit differently. I'm going to be talking about geotechnical engineering and what it means and its history and applications of it and whatnot. And Peter will be talking more specifically about the company CN Ryzuk and Associates. Like that? That's pretty good, eh? Can't do that on a PC. Anyway, just kidding. So we'll start by just a summary of CNRA. They're a geotechnical consulting firm located here in Victoria. They're actually one of the largest geotechnical firms in Victoria, but they only have 6 full-time engineers, which I thought was kind of weird. I think they'd have like 50 or 60 people working there, being the largest, but apparently 6 people is what's considered to be large. They have 3 technicians, and they also have 2 office staff. So being one of the largest companies in Victoria, they handle 80% of the work. So basically 8 out of 10 buildings that you drive by, they've probably had something to do with. And while we were there, we had an interview with one of the engineers, whose name was Lane Campbell. He's been working there for 2.5 years. So we had a sit-down interview with him that lasted for about an hour. And we talked a lot about the history of geotechnical engineering and the applications of it. And then we had a tour of the property, and we saw some of the different things that they do there. So what does a geotechnical engineer do? I had no idea 3 weeks ago when Norma gave me the thing. I thought it was something to do with like satellites, because I thought GPS, geotechnical, kind of sounds similar, but apparently I was way off. So what they deal with soil. Not super fascinating, dealing with dirt all day long, but it's somewhat interesting. One of the main things they deal with is land contamination. So say you have a gas station, say it's been on a property for a few years or maybe 20 years, and you want to take it down and put up a condominium, you have to have a geotechnical engineer to come in, and he has to inspect the land and take it back to his lab and see, is this safe? Can we put a house on here? Is grass going to grow? Is a tree going to die if we plant it here? So that's one of the things they deal with, which is kind of a niche that you won't find in any other branch of engineering. Second thing that they deal with a lot are landslides and instability. I know over Christmas I would watch BCTV a lot, and you would see almost every week there'd be a landslide in someone's house, $300,000 house in northern Vancouver. It would just slide right down the bank, and that's all because of in the past poor geotechnical engineering. So they would bring in a geotechnical engineer, and he would deal with what do you need to do to brace this slope, and you need to plant some grass on it. Sometimes that's the simplest solution. All you have to do is plant grass, and it will hold that slope. The third thing they deal with, which is the majority of their work, is in excavations. So as you can see from this graphic right here, cut slope is one of the main things they deal with. So when an excavator like that, say that weighs 3,000 tons or whatever on that place of dirt, you're going to have some pretty strong clay to hold it up at quite an angle like that. So if it's loose, granular sand, that's going to have to be a very gradual angle, where when it's strong clay like this, you can have it on a steep angle, right like that. So some of the history of geotechnical engineering, it's the most recent field in engineering. The founder of it, his name was Carl von Terzaghi, and there's a nice little picture of Carl. He died in 1965, so it's a very recent branch of engineering. His book he wrote there, and forgive me if I pronounce this wrong, Mechanic, that was his doctorate, and he wrote about the majority of the things that we're going to be learning in our soils class. He wrote about in his doctorate, and these were things that weren't even known until just half a century ago when he came up with them. So some applications of geotechnical engineering. What happens when you don't follow what a geotechnical engineer tells you to do? Well, before we had them, we had the Leaning Tower of Pisa. One side of the tower, it was soft clay, whereas the other side's hard clay, and the tower subsequently started to lean. And current geotechnical engineers think that in about 100 to 150 years, the tower will fall all the way over. So that's an example, an ancient example of what happens when you don't use a geotechnical engineer. A modern day example would be the Kansai International Airport in Osaka Bay, Japan. It was built in the middle of the bay, and I don't know if you watch TLC a lot, but they often show shows on this. And since it's been built, it has sank 8 meters. Not 8 feet, 8 meters. So you can imagine the tremendous structural problems that they encounter in that building. Some stairwells, they just drop off because they were built when everything was 8 meters higher. So if the geotechnical engineers were involved in there, they wouldn't have had the problems that they've had. Some examples of good things that geotechnical engineers do when they are involved: Boston's Big Dig. It's a project that's currently underway in Boston where they are replacing a lot of the traffic that goes above ground. They're putting it underground. They're going to have a 10-lane highway up to 20 meters below the ground. So that's pretty insane. If you can think 10 lanes of traffic zooming underneath 2 layers of subways, and they're going to have a 10-lane highway with all this traffic. Of course, there's lots of engineers involved there, electrical engineers, mechanical and civil, but a huge amount to do with geotechnical, because they actually go underneath the river there. So you have to make sure you know a lot about the slope stability there, because you don't want the top of the tunnel falling down on you. So now that I've talked about some of the applications, we'll get more specifically into the background of CNRA, and I'll pass it over to Peter. Now he can talk more about the actual place that we went. Here.
Thanks, Brad. I'm going to talk to you obviously about the company that we went to, CN Ryzuk Associates. It was started by Chris, so we're going to give a little background on Chris. He was a graduate of University of Alberta's geotechnical engineering program. I think he graduated in 1980. He wrote his master's thesis on the performance of reciprocating machine foundations. I'm sure you all know what that means. After he wrote his master's thesis, he went on to get his professional and engineer title. For some time after that, he worked until he started his own little company called CN Ryzuk Associates. The company was started in 1987. It was just a small company back then, just Chris. But they got their start by filling the niche in Victoria's engineering community, that there weren't really many geotechnical engineers to provide work. So they were able to get that started with small projects that maybe bigger companies like Levelton wouldn't take on. So that's how they got their start, and today they are some of the most respected professionals in the community, and they're an integral part of any project, or a derivative part if you want a little math joke. So some of their projects, they have, as Grant said, 80% of the work, so they have a vast library of all the projects that they've done. We saw it was 3 full walls, about 8 feet tall, 8 feet long, and it was just full of bookshelves, full of all their files and everything. So they're busy. One of their projects that they've worked on recently was the dockside lands in the Inner Harbor. They're trying to develop this area so they could build on it. So CN Ryzuk Associates was commissioned to create a report on the soil conditions there, and they discovered that it's still safe to build there, but they did report that there was some soil contamination due to maybe foreign fill in the dirt, and they also said that there's a high water table, and water table means where the soil is just completely saturated with water. They also found that there's uneven bedrock in that area, so it could cause problems if you're maybe driving piles for stability. Moving just up the street, figuratively, they also worked at the site of the Save on Foods Memorial Arena. They were part of the engineering team there, and they performed some engineering testing. Lane was a little tight-lipped about what they did there, but me and Grant believe that is maybe some soil compaction testing. That's a huge load to be putting on the soil. Maybe some stability analysis, since there is a slight grade to that area. And also maybe some moisture content testing, because it is somewhat close to the Inner Harbor. Stepping away from some of their major projects, they've also worked at the pier in Sydney. It's upscale waterfront property. They've also worked on consultation for seawalls and retaining walls. They also consult when it comes to sewage projects and things of that nature. They also help produce geological maps of Vancouver Island and the area, so we know how old the rocks are and things like that. So obviously with these amounts of projects, they're pretty busy people over there. So you might wonder, what what an engineer there might do in a typical day. So they don't have any junior engineers right now. They're all full-time senior engineers. So they're all responsible for the calculations and all the design and consultation. And one time or another, one engineer might be working 20 to 30 projects. And they won't work on it every day, but you know, they'll change projects daily. Chris, on the other hand, Chris, on the other hand, he has a magnified workload, of course, running the firm himself. He might have 50 projects at a time that he has to deal with. So, you know, he also has to be on the phone with customers, giving consultation and advice on what he thinks. So, they're not slackers. Although this is all kind of dry material, Lane gave us a few interesting facts about geotechnical engineering. One thing is that, I guess it's kind of like wine, it gets better with age. You become a better geotechnical engineer just on experience. Lane said, we asked him what kind of equipment might you use to go out and testing, and he said, oh, we just generally use a probe, a metal probe. So we thought, do you just go out and poke it in the dirt and say, yeah, that'll hold, or that won't hold? But that's generally the gist that he gave us, is that, you know, once you've had 5, maybe 10, 15 years of experience, you can just tell some properties of the soils just by poking it. So, you know, whereas with structural, it's very by the book. You might have a steel column and you think, I need this grade of steel, and that's it. Also, with geotechnical, it's very regionally based. So, for example, Lane, he couldn't go to Edmonton, for example, and say, all right, this dirt will hold or it won't. You become very accustomed to the local soils and the clay. And Victoria's a lot of clay. And speaking of Edmonton, actually, he told us that engineers there, they might have to deal with a kind of rock that's under the surface that when it's exposed to sunlight, it'll actually disintegrate within a few hours. So that's a major source of error for them. I know it's not the most interesting fact, but with soil, water tends to move in a lateral or sideways movement. I thought it moved downwards, but you know, Lane told us otherwise. In conclusion, we had a great time there. We learned a lot about geotechnical engineering, which we couldn't learn from the website. A lot of it is, you know, you have to have someone in the know to tell you about it. And we had a great time once we got there.
Yeah, it turns out that 39 Carson Road isn't the same address as 93 Carson Road. So here we are driving through a residential area. And I think, okay, well, I know some engineers work out of their house. You know, we go up to the house, knock on the door. You can imagine the surprised look on that lady's face when I said, hi there, we're here to interview. What? So I was all flustered. We got there 20 minutes early, so I managed to tap into our wireless internet signal, and I went onto my Hotmail account to see, oh, nuts, it's 93. So we got in the vehicle and we drove 3 blocks down the road, and there we found a nice big sign, CN Ryzuk. So that was kind of interesting. Anyway, do we have any seated questions? Oh, I mean, yes, Barbara.
What qualifications are needed to work at CN Ryzuk?
I'll take that one. Her question was, what are the qualifications for working at CN Ryzuk? You definitely have to be committed to your work. You have to be able to multitask well, because like I said, 20 to 30 projects. I mean, they showed us their offices, their desks. It's just a pile of plans and papers and everything.
Dirt.
So, yeah, dirt. So you have to be organized as well. You also have to have your professional engineer degree, or not degree, but title. If you don't, you could work under the supervision of a professional engineer. And that's about it for that. Are there any
Anyone
other
else?
questions?
Garrett?
Were there any other applications for cut slope aside from excavating?
Yeah, when you, so his question was, does cut slope apply to anything else besides excavation? If you dig anything steeper than 1.6 meters in depth, you technically should have a geotechnical engineer there to certify it. But also, if you're building a highway, you maybe not realize this, but as you're driving up the Malahat, if you were to get out of your car and step there, there's quite a slope, and then starts the natural flow of the mountain. So the strength of that dirt that's put in there, the geotechnical engineer has to know that. And actually, in an earthquake, Lane said that the entire highway would move 15 inches back and forth in an earthquake, just this fast. And of course, you have to know a lot about the strength of the dirt to make sure it's not just gonna completely fall over. Any other questions?
Can we
John.
just take one more? since
Yes,
we're
one more,
all
that's
short
all we
of
need.
time?
I have a question from Grant, for Grant.
Thanks, John.
What did Lane say were some of the most important skills learned in college?
Well, interesting enough, he said the most important class that you can take in college, sorry, is English. I don't mean to brown nose here, but that's what he said. Truthfully, that's what he said. He said, yeah, I thought it was math and physics too, but all day long you're giving presentations and you're typing up memos and you really have to know your stuff. He said the first thing he handed in, Chris handed it back to him and had red stuff all over it. He said, redo, this is terrible. We can't send this out to one of our clients. This is awful. So it's true. English is important. So
Although statics is a close second.
yeah, so in conclusion, please direct your, can't do this on a PC either. Watch this. Ready for this? No, it's not that amazing.
That isn't right.
You didn't go to the questions.
I'm sorry,
okay.
Grant.
Now, here, we're ready. Ready for this? Bloop, bloop, bloop. Anyway,